Hello, welcome back. So today, as part of a data modeling masterclass series that we are having, so we are bringing one more video, and this is one of the most important video, and we will be discussing about normalization. So the normalization comes under logical data modeling. So there are, like as you saw in the previous video, there is a conceptual data model, logical data model, and then actual implementation where physical data model is there. Briefly discuss about first normal form, second normal form, third and BCNF normal form, and fourth and fifth normal forms. So please watch the video till the end, and if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So now let's start exploring. So in the previous set of video, in the previous video, we have just seen the importance of normalization. What happens if we don't normalize the tables, right? So and that in that video we have seen. In this current video, we will see as part of the continuity of the previous video, we will explore the different types of normal forms, right? And the normal forms will start from the first normal form, right, which is a, we call it as a 1NF. So it's a very initial step in the normalization process, and the table is one first normal form or 1NF if it satisfies the below conditions. What are the conditions? All column all column contain atomic indivisible values. That means each column should hold a single value, right, not a set or a list of values. That again we will see, take example just now. And each column contains value of single type. That means all values in a column must be of a same type, and column must have a unique name. So column should always have a unique name, like a particular column if you're naming as a first name, and again there should not be a first name, so that should be unique. The order in which the data is stored doesn't matter. The table should be treated as a set of rows without any specific order. So because like when you create a employee table, so employee ID, first name, last name, the date of birth, department, so that need not be in order. So basically it's a good practice, or just a convention. We use IDs at the first start beginning of the table, but it need not be at the beginning. It can be in any of the order. So that is the importance of it. So that's the fourth point, right? So this is what we call it as a first normal form. So let's take an example to understand this in detail. So example of first normal form, we'll take a sales table here, and which is a non 1F. That means it is not a first normal form. It is not satisfying the first normal form. So consider this like table, and if you see here, like basically this table stores sales transaction including multiple products sold in a single transaction. So that represents in a single column basically, right? And so multiple products are there in a single sale, and all the products which are sold, it is storing in one particular attribute itself. And so this will not satisfy the first NF. What it is violating, as you can see, all columns contain atomic values, and each column contains value of a single type. So it should be indivisible, but here it can be divided, right? So it can be divided. This is one, and this is one, and this is one, right? So you can divide it, literally can divide it. And so each column contains a value of single type. So it should be single type. Single type anyway it is satisfying. But the important thing here is it should be undividable, but it is dividable here. So that is the important point. So how do we do this? How do we apply first normal form here? By decomposing the table, right? So so here actually if you see, we are not decomposing the table. So that's the important point, right? Like decomposition is happening actually, but it is not into a different table. So we are decomposing the rows, right? So if you see, like the first particular row is actually split into two rows, and the product is getting a separate value here. The first is split into TV DVD player, TV DVD player. rest everything is same. Sales 1 5 23 is actually same, and whatever it is, it's exactly same. So by this, what we are trying to do is here is like we are applying the first normal form. The first normal form is applied. To convert the sales table to first normal form, we need to ensure that each column contains the atomic value. So now this product column also contains the atomic value. So then this involves the splitting of the product columns in this case, so that each product basically is in its own in its own row. Okay, and so this we are calling it as a finally first and compliant sales table. And the important point here is to note is atomic value. Each product is now stored in its own row, making its value as atomic. And although also it's also if we talk about data redundancy here, although the sales ID is getting redundant here, sales ID, customer name are repeated for a transaction with multiple products, the table now properly represents each product sold in a transaction. So you might ask me, okay, why it is redundant, getting redundant, right? So that answer is there in the next normal form. But here the intention of first normal form is because we are going sequential. First normal form is the first step. So here first thing is we are able to represent each product sold in a um, um, like in a particular row here. So that's the whole intention. For this, whatever duplication is happening, we have the solution in the next coming normal forms. So the next is the second normal form. So where so the condition of second normal form is if it can meet it is already should be a first normal form. So that is a basic necessity. And the next is it has no partial dependency. So what that means? All non-key attributes must be fully functionally dependent on the entire primary key. This means that if the table has a composite primary key, no non-key attribute should depend on only part of primary key. So let's so this might sounds complicated. So what that means, it has no partial dependency, right? So let's understand that with the example. So as we said, the input for second normal form is the first normal form. So here, as you can see, we have taken a sales table again, which is comes from the which is already a 1NF compliant. And here with this, what we are trying to do is consider this sales table, which is 1NF, where the primary key is composed of both sales and product key. Sales and product key, right? Sales ID and product ID. So now let's take example of second normal form so that you can understand much better what exactly the second normal form means, right? So, so as we said, the input for the first second normal form is definitely comes from the first normal form. So that's why we have taken first normal form compliant sales table here. And so as you can see, this sales table is having a um, where having a primary key basically, and this should be a composite primary key. We cannot just use the sales ID or product ID as a primary key here. So basically sales ID and product ID both combined as acts as a primary key. So that's why these are this we can call it as a composite key here. And here the customer name and the sales date depend only on sales ID, right? And not on a combination of sale ID and product ID, creating a partial dependencies. So in this second normal form, like how do we convert this to second normal form, right? To convert to the second normal form, we need to remove the partial dependencies. So we can achieve this by creating a separate table. That means decomposing a table for entities that are dependent on only part of the composite primary key. So that means you need to carefully take it out, right? So here product table can be definitely a separate table. So you can create a sales table and product table as a separate here, and that's how you are able to segregate and remove the dependencies or remove the redundancy here. So as you can see here, the product table is become a separate table now, right? So, which is having a sales ID, product ID, and the combination will actually have the actual product here. And the sale ID, it can actually have the sale ID. With that sale ID, you can go and check exactly what exactly you want to perform, right? And sales table, that the table now only contains only the attributes that are fully dependent on sale ID, right? And also the sale product table, if you closely observe, this table maintains the relationship between sale ID and product ID along with the product details, ensuring that each non-key attribute is fully dependent on composite key. So that's what, as you can see in the second normal form that we have seen, right? That was the main. It has no partial dependency, that we are able to achieve with by splitting up or decomposing the tables into a sales table and sales product table. So this particular tables are now 2NF compliant tables. So let's move further. Before moving to the further, right, so hope you are able to understand this second normal form. So it might be quite confusing, but just take a paper and pen and try to understand this. So second normal form, basically by removing the partial dependencies and ensuring the non-key attributes are fully dependent on entire primary key, so we are able to achieve this. And this project process, actually we are reducing the redundancy, and further we are able to organize the data into logical related tables, so that will in turn, what we are talking about, data integrity and maintainability has been taken care. So now let's quickly jump to the third normal form. So third normal form is a normal form which can be satisfied with the following conditions. So it has to be already a second normal form, right? And, then the next thing is it has no transitive dependency. So again, by words we will not be able to understand. We'll need to take example, right? And we will have to take a 2NF compliant sales table here again, because like that is a first criteria, right? And then here category, whatever we see, right, is transitively dependent on product ID. So electronics, whatever we are seeing, right? So electronics, so these are dependent on product IDs. Okay. And by creating separate table for entities with the transitive relationships, so we can achieve the third normal form. So how can we do that? So we are basically segregating the sales table and product table here. So product table, whatever you see, 101 and TV, electronics, so 102, whatever, so you are seeing, so that you can take it out here. Otherwise, what would happen is, so there would be case again, it might lead to a duplication, right? So suppose someone buy again TV, and so product ID is again 101, and it is again electronics. So if there are 1 million people buying TV, in that case, this particular data is repeating 1 million times, right? So that's where you are segregating that, you are decomposing the product tables into a separate table here, so that you just refer that product ID here whenever the sales happens, right? So that you are not actually duplicating the entire row. So you just define 101. So for this definition of 101, you have to go to the product table here and understand what exactly it is. But you are not making this TV, electronics, so those entry in this table. So then you are saving the space and removing the complexity and maintaining the data integrity also, right? Because if tomorrow you want to add a new product category here in the product table, you can just go and add here, or update. So if you want to update TV into television, so in that case you can just update in this one particular table. That's enough, because it's all ID dependent, right? Otherwise, what would happen if you are storing here as a television? So if you want to update everywhere television, 1 million or 3 million television buyers, in this sales table has to be updated, right? Those many records, which can lead to inconsistencies. So what exactly we did in the third normal form is the table, the sales tables, the sales table what we are seeing here. This table now contains only attributes directly dependent on the primary key. That means sales ID and product ID, right? And so these are like composite keys as we said, right? And product table, this table contains product ID, product name and category, ensuring that category is directly dependent on product ID now. Okay. And by removing the transitive dependency using third normal form, we are ensuring that non-key attributes are only dependent on the primary key. So that is what we are achieving using third normal form. So this process further reduces the redundancy and ensures that the data is structured in a way that enhances the data integrity and maintainability again, right? So now let's jump to the another normal form, which is BCNF, and we also call it as a Boyce-Codd normal form. So, and it is a kind of a more stricter version of the third normal form, we can say. A table is a BCNF if it satisfies these conditions. First of all, it is already a third normal form, which is a previously what we have seen, and it should satisfy this condition. Read it carefully. For every functional dependencies x belongs to y, x must be a super key. Okay, a super key is a set of attributes that uniquely identify a row in the table. Is a set of attributes. It's like a composite key. End of the day, right? So again, without the example, we cannot understand it very easily. So let's take an example. So this is a non-BCNF table, but it is definitely a 3NF table, 3NF table, yeah. And why we are calling it as a non-BCNF table here is so this particular table that we are considering where the department can be associated with multiple managers, all right? And each manager manages only one department. So as you can see here, this particular manager, okay, he manages only one department, that is department ID 1. But so there can be another manager who is also managing department ID 1. That means there might be like a sub task or sub divisions that they are working on. But end of the day, what we are saying is if there is a manager here, manager M1, so he can work into a department ID 1, and M2 is also working for the department ID 1. Okay, that means uh, department can be associated. So what we are saying is department ID 1 can be associated with multiple managers, like say manager 1, manager 2, and manager 4, whatever. But if you the other way is not true. So it's always like one manager is maximum he can handle only one department. So that is what in this particular case, that is what we call it as a x belongs to y, and x must be a super key. Okay, what must be a super key? X must be a super key. So again, we will take example how we will make that x as a super key. We will see that. So now, so this particular table is getting split into or decomposed into multiple tables. So in this example, what we did is department ID. So wherever we are, so what we took as an example, x belongs to y, right? In this example, if you carefully see, x is nothing but a department ID, and that belongs to department name. Similarly, manager ID belongs to department ID. Because why it is like this? Because one particular manager can handle only one department. right? So that is where it is. And manager ID is not a super key in this case because it does not uniquely identify. So suppose if you take manager ID as a unique key, it doesn't help because it is not uniquely identifies a particular row. Okay, so that's why to convert the BCNF table, we need to ensure that every determinant is a super key. This typically involves decomposing the tables. That is why we are starting decomposing the table. And here the key point is the table. This particular table contains department table, right? Contains unique department information, right? With the department ID as a primary key. And even coming to the manager table, so this table links the manager to the department. Links manager to the department, ensuring that the manager ID is uniquely identified and department ID is appropriately referred, right? So manager ID, how is able to relate is using this department ID. Okay. So what exactly we did here is by ensuring this that every determinant is a super key, BCNF is eliminating a situation where non-super key attribute determines other attributes. Okay. So let's move to the fourth normal form. So fourth form is a normal form if it satisfies definitely the previous condition, that is BCNF, Boyce-Codd normal form. It should satisfy, and it has no multi-value dependencies. Again, let's take example. So this is a non 4NF employee skills and certification table. So now let's jump to the example of fourth normal form. So in this we have taken a non 4NF employee skills and certification table. So that means we want to track the employees and their skills and certifications, whatever they have done. And in this table, employee ID determines both the skills and certification independently, leading to the redundancy. So here, if you see employee ID, what it is actually doing is determining the both skill and certification. Okay, independently, leading to the redundancy, because that's where it is getting redundant, right? Like Alice, Alice, Alice. So the same person and the different skills and certification, and it is creating three rows for that particular person, which is not exactly the right thing to do. And how do we decompose this using the fourth normal form is, so we actually convert the table into fourth normal form. We need to separate the multi-valued dependency into distinct table. So what is multi-value dependency here is so this particular employee table, right? As you can see, this table is captures the relationship between the employee and their skills, removing the multi-value dependency of the certifications. So now this guy is purely capturing the uh, just a skills, okay, and this particular table is capturing the certifications. It's basically it's segregating the things here. So that is where the intention of this particular 4NF form was there, right? The intention of 4NF form was to kind of it has no multi-value dependencies. So now we have removed the multi-value dependencies because the certification table is different. So there is no dependency between the certification table and employee skill table now, and they capture these as a separate into the separate tables now. Okay. So in the certification table now in this case is capturing the relationship between the employee and certification, removing the multi-value dependencies again. Okay. Here it is a multi-value, right? Because each employee, so this particular employee having a skill and having a certification, and this particular employee, same employee, was having a particular skill and having a particular certification. So that's been removed out. So it was creating a confusion, right? So what is it a combination of these two skills or what exactly? We didn't know that. Okay. So now this Elise, if you see, his particular skill Java and his particular skill is Python, and his certifications are PMP and Scrum. Okay. So let's take this particular PMP was not there here, right? In that case, this record only will not be there here. Getting my point, right? So if this PMP certification is not there for Elise, even this record will only be removed from this table, because uh, that's how the advantage of 4NF form here. Okay. Hope this was like you understood the fourth normal form, and now let's quickly jump to the last and fifth normal form, and it is also called as a project join normal form. That is the name that we are using, and it is the highest level of normalization. And we can call a table as a or set of table as a 5NF compliant if it is already a fourth normal form compliant. And the other thing is every join dependency in the table is implied by the candidate keys. What that means, we'll take example now. So example we'll take with start with a non 5NF compliant, which is a consultant allocation table. So a particular consultant one would be working in multiple projects, and each project can be for a different clients you might be working, right? So just this is a table that we have, and so it is not a actually like a 5 normal form compliant. So 5 normal form deals with the case where the information can be reconstructed from smaller pieces of data, and this aims to reduce the redundancy of decomposing tables into smaller tables. So as long as those small tables can be joined back together to create a original table, so without a loss of information, so we can implement the fifth normal form. So we can see here what exactly we are trying to do is consider a table that records consultant work on a project from for a different client. So we are segregating the consultant and the project he is working. So consultant is working for 101 101. So that has been clubbed into one record here, right? And so in the second table, what we are doing is we are tracking the project client table. So that means from the project perspective, what exactly uh, for each project are belonging to how many clients, right? So that we are tracking here. So in this we can see all of the records. Okay. And the third one is you can see consultant client table. We just need a consultant and the client here. So for first one, there's a 101, we have tracked it, and again for the first one is working for another client ID, this person 1002, and second is working only for 1003. So you might ask why exactly we are doing all this drama, right? So the thing is, see, end of the day, it's all about reporting, analytics, and the performance when you're doing the report and business analytics. So if you do this, if you are using this table, it might create a lot of confusions when there is a millions of rows. But if you split this into multiple, decompose into multiple set of smaller chunks, so then you can easily generate any sort of reports. So you can, now you are just explaining the 3 rows, we are decomposing into 3 tables or whatever. So imagine the 30 rows are decomposed into 30 tables. So then you can imagine the power of this kind of a normal forms, which can easily help kind of create a reports. So end of the day, reports will need to be more performance intensive. So if you're not reducing the volume or redundancy of the data, so then the reports will be very slow, and no matter what like performance or like scalability you use, so report might still uh, become slow, or analytics can still become slow because the data is not properly modeled basically, right? And finally, like if you want to summarize this learning that we have taken in this last two videos, right? So normalization is basically a systematic approach, right? We've already seen that, and to organize data in a database to reduce redundancy and improve data integrity. So it involves a series of steps known as the normal forms that we have seen, each addressing a specific type of anomalies and dependencies. So the process starts with the first normal forms, which ensures that all the columns contain atomic individual values, and that each column contains a value of a single type. So then comes the second normal form on top of the first normal form, which builds on by eliminating the partial dependencies, where non-key attribute depend on only part of the composite primary key. The third normal form goes further by removing the transitive dependencies, ensuring non-key attribute dependent directly on the primary key, not on the other non-key attributes. And after that, we see BCNF is a stricter version of a third normal form, requires that every dependent uh, determinant be a super key, eliminating the situation where non-super key attribute determine other attributes. So we have again, after that we see 4NF addresses multi-value dependencies, where one attribute uniquely determines another, ensuring that these dependencies do not cause the redundancy. So finally, the fifth normal form, also known as a project join normal form, ensures that the table can be decomposed into smaller tables without losing the information, addressing join complexities, dependencies, etc. Right. So this is about the normal forms, and with the examples that we have explained, and hope it was easy. It was easy to understand. And if you find any difficulty, I would recommend you to please pause the videos and take down the notes so that you can understand it much better. So further, if you have any questions, feel free to comment in the comment section. And I hope this was useful. Thanks for watching.